Today's video here is a nice problem. It's coming from Russian Mathematics Olympiad edition 1990. Here is the following statement. Find all x, y as a positive integers. Satisfy this following equation. We have 7 to the x minus 3 is multiplied by 2 to the y equals 1. Okay? In fact, this is very nice and straightforward problem. Maybe there is several ways to solve this one. I'm going to do it in very simple way. So you guys, you can give it a try to this problem prior to the solution. Go ahead, pause this video whenever you come back to save solution. Okay, so if you have any additional method, just post it in the comment section below and let me know what you get. Okay, now let's go ahead and jump into this one. So first of all, I'm going to consider obvious solution by taking y equals 1 as a first value. So for y equals 1, I'm simply going to insert this value of y and find x. Okay, so I get here 7 to the x minus 3 is multiplied by 2, which equals 1. This one equivalent, so we'll have 7 to the x. So this one is equals 7. It's clearly is given as x equals 1. So here is a first solution. We get x equals 1 and y equals 1. So now let's move on to the next value. So for all y is super equal to 2, I will have the following. This equation will be reduced to the first. I will have 7 to the x. This one is 0. This one is a congruent to 1 mod 4. Okay, so get 0 because this one is divisible by number 4. Also this 7 is 8 minus 1 to the x. 7 to the x is the same as 8 minus number 1 to the x, which is a congruent. This one is a congruent to minus 1 to the x, which is a congruent to 1 mod 4. Okay, this one is clearly x must be even. Let's set x equals to n. Okay, let's take this value of x and insert it back into the original equation. So I get here 7 to the 2n. By taking also number 1 to the left, I get minus number 1 equals 3 is multiplied by 2 to the y. Okay, always we are working on this condition, y is super equal to 2. So I have a difference of the squares. I'm going to factor out that on the form of the product. So I get here 7 to the n minus 1 factor 7 to the n plus number 1, which equals 3 is multiplied by 2 to the y. At this point we cannot say anything about this one because this one is an even, this one is an even, so we don't know what's the status of this one. So we need to work out more in order to determine what's the value of this one, what's the value of this one. Okay, now we are not going to work on y is equal to 2. I'm going to add one more value. So before we move on to the next value, which is y is equal to 3, I'm going to check y equals 2 is a solution for this equation or no. Let's take the y equals 2 and insert it back into this one to see what's given us. I get here 7 to the x minus, we have 2 square here, which is 4. 4 is multiplied by 3, which is 12. I'm also going to take this 12 to the right. I get 12 plus 1, which is 13. I get here 13. This clearly is not a solution. It's impossible. So which means y must be super equal to 3. I will tell you in later while why we are not using mod 8, we are just using mod 4, even though we have y is super equal to 3. Okay, so I'm going to reduce this one to mod 4. So which means this product 7 to the n minus 1 factor 7 to the n plus number 1 is a congruent to 0 mod 4. Okay, because since we have 2 to the y, I will have y equals 3. I will have 8 here. 8 is always divisible by number 4. So whatever the value of y which is super equal to 3, this statement is true. Okay, now we will have 4 divides either one, this one or this one, but we don't know which one 4 divides. We are going to force one of these must be out of this possibility. Okay, we are doing that by the way of contradiction. So by the way of contradiction, suppose 4 divides 7 to the n minus number 1 by using this assumption. So according to the divisibility statement, I get 7 to the n minus 1 equals 4 is multiplied by k, where is k is a some positive integer. Okay, I'm going to take this value and insert it back into this one. I get 7 to the n minus 1, it will be replaced with 4k. So what about the other one? So I'm simply going to add number 2 on both sides. I will have 4k plus 2 here. At the same time, since we have number 4 as a multiplier, I'm also going to take another extra number 2 out of these things, make it 8, which is 2 cubed. 2 cubed, factor k, factor 2k plus number 1. This product equals this one. 3 is multiplied by 2 to the y. This is the reason why I'm reducing this to mod 4, not mod 8, because I'm going to divide both sides by 8 here. Okay, because I want to save this one as an integer. If I'm going to use mod 8 here, while we have y super equal to 3, I don't have this one, I will have more. I will have the exponent is growing up, because if this one is a multiple of 8, I will have 8 here, and also I'm going to extract another number 2 out of here. I become 16. So 16, we cannot divide this one by, you cannot divide this one by 16 while we have just y super equal to 3, because if y equals 3, we'll have a problem. This one becomes not integer. Okay, now we are okay. Now since we have y super equal to 3, now we are allowed to divide both sides by 8. Okay, I will have here, I will have a reduced product. So by dividing both sides by 8, I get k factor 2k plus number 1, which equals 3 is multiplied by 2 to the y minus 3 here. Okay, since we have y super equal to 3 like this. Okay, if you take a look at the left hand and the right hand side of this equation, we have GCD of this one equals 1. So GCD of these terms equals 1. Also this one must be equals 1 because of this one. Okay, and also this one is an odd, this one is an even. It's automatically GCD of this one equals 1. So GCD of this one equals also 1. Okay, since this one is an odd, is going towards number 3, and k must be even. Okay, and goes towards this one. Okay, so which means k is going to take 2 to the y minus 3 as an even integer, and also 2k plus number 1 is going to take number 3. So I'm simply going to solve this nice equation. So I'm going to solve for k. I get here k, I get here 3 minus 1, which is 2, 2k equals 2, which k equals 1. I'm simply going to take this value of k and insert it back into this one to find y. So I get here 1 equals 2 to the y minus 3, which means this exponent y minus 3 equals 0. Okay, in the other word, y equals 3. Y equals 3. Y equals 3. I'm going to take this value of y and insert it back into the original setup. I get 7 to the x minus, we'll have 2 to the 3, which is 8. 8 is multiplied by 3, which is 24. By taking this 24 to the right, plus number 1 becomes 25. 25 is the same as 5 square. It's clearly, it's a contradiction. It's impossible, because we get the left hand side of this equation is a power of 7, but the right hand side of this equation is a power of 5. Which means the assumption that we have chosen before was wrong. So which means this one, 4, cannot divide 7 to the n minus number 1. In the other word, 4 divides this one, 7 to the n plus number 1. Okay, let's get rid of this one and move on to work on this one. Okay, now we have concluded from this one, 4 divides 7 to the n plus number 1. According to the divisibility statement, we get 7 to the n plus number 1 equals 4 times is multiplied by m. Okay, what is a m? Is a some positive integer. Okay, I'm going to I'm going simply to take this fact and insert it back into this product. So I get here 4m. So what about the other one? This one, I'm going to subtract -2 from both sides. If I'm going to put 7 and -2 here, in order to transfer this one into this one, I get also 4m -2. 4m -2. At the same time, I'm going to take number 2 out of this thing as a multiplier. With this number 4 becomes 8. In the other word, I will have 2 to the 3 factor m factor 2m minus number 1, which equals 3 is multiplied by 2 to the y, like this. Okay, I'm going to do the same job that I have previously, dividing both sides by 8. So I get here, I get m factor 2 to the m minus 1 equals 3 is multiplied by 2 to the y minus 3. Okay, because since we have y is equal to 3, now this one becomes an integer. Okay, at least it can be a number 1, because if y equals 3, I will have 2 to the 0, which is 1. Okay, which is an integer. So same thing here, GCD of this one equals 1. This one is a power of 2. M must be even. Okay, so which means m equals 2 to the y minus 3, and also 2m minus 1 equals 3. So in the other word, m equals 3 minus m equals 4 over 2, which is 2. So I get the value of m equals 2. I'm going to insert this value of m into this one to find y. So I get here 2 to the y minus 3 equals 2. Exponent is 1 here. Thus y minus 3 equals 1. In the other word, y equals 4. Okay, so we found y equals 4. Now I'm going to take this value of y and insert it back into the original equation to find x. Now we get y equals 4, implies I'm going to insert this value of y into this one to find x. I get 7 to the x, which equals 1, plus this term, because I'm taking this term to the right. I will have 2 to the 4, which is 16. 16 is multiplied by 3, which is 48. Together is given as 49. Is the same as 7 square. So I get the solution. I get x equals 2 because of this exponent, and y is already number 4. So I get only 2 solutions for this equation. Okay, so I have ended this video. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.